we started discussing about memory management, how Python manages the memory. Yeah, good morning, Naren. And we discuss the first slide, like why should you care about the memory management? Uh, we've seen that knowing about memory management helps you to write the code very efficiently. Okay, and we also talk about like creating code that performs manual memory management will be cleanly and thoroughly non-trivial and complex task. And while estimates vary, it is arguable that manual memory management can double the development effort for a complex program. Okay, we elaborated this topic and we discussed about memory allocation in other programming languages and memory allocation in Python. We've seen that in C++ especially, there are two types of memory allocation. One is called static memory allocation, the other one is called dynamic memory allocation. In static memory allocation, uh, generally like you create the variables or the way you create an array variable in C and C++ is a static way of creating or static way of allocating the memory. One thing is very clear that you need to use the data type name to declare the variable, because based on the data type it will allocate the number of bytes and all. So the data type is mandatory in other languages like C, C++ and Java, and the way you allocate the memory is use the data type name followed by the variable name. If it is an array, then you will use the subscript. We took an example of an array because it suits to explain you what is meant by static memory allocation. We've seen that if I try to keep this parenthesis empty or the subscript empty, we've seen that in C, C++ we will get an error that size is required. So you must provide the size of the array at the time of writing your code, because it will allocate the memory at the compile time. Meaning, when you compile the program, then the compiler looks at this line and the memory will be allocated. Okay, it is not going to allocate at runtime. So that's why the two major problems you have seen that it's fixed in size, that you cannot grow or shrink this memory size, and also it required continuous memory. So we took an example of like taking a seminar. So if you have a seminar hall and if you wanted to arrange the chairs statically, then before seminar starts, you will place all the chairs here, maybe 100 chairs or 500 chairs. Based on the capacity of the seminar hall, you will put the chairs now. But that approach is like I told you, that as it is fixed in size, so it will be lot of wastage of memory, because what happens if only 10 people comes, then remaining 80 chairs will get wasted if you allocated 100 chairs into that. Okay, so that will be like wastage of memory. Then we've seen that to overcome this problem, C and C++ has provided you one more thing called dynamic memory allocation. Okay, Rajshekhar says, yeah, I lost connectivity. I'm repeating, Rajshekhar, that's what I'm doing. Always for first 5 minutes, we'll always do that. No worry. If anybody missed the session, join on time so that we just have a quick review for 5 minutes. So that's what we are doing, Rajshekhar. Okay, I hope you will follow. So dynamic memory allocation is nothing but allocating the memory at the runtime. So now the problem of static memory allocation has been solved, that as it is fixed in size, so here it's not needed to be fixed. Okay, based on the requirement, you can allocate the memory. Like every time you can tell that, give me a one block of memory. Like you're asking a chair, so something similar, you can also ask to allocate a one block of memory using this particular statement in C language. Do not worry about the syntax. Okay, if you are from C background, then you can understand the syntax. Otherwise, no worry. This line is actually wanted to tell you that how complex it will be to tell in C language that please give me a block of memory. So you need to ask C language to give you a block of memory. It will give you a block of memory. So again, if you need one more block of memory, you can ask him to create me another block of memory. Similarly, if you require 20 blocks of memory, you will execute this for 20 times, then 20 blocks of memory will be allocated. If you want 100 blocks, then you will execute this 100 times. So based on the user requirement, you will execute this statement to allocate one block at a time. Okay, one block at a time, not all 100 blocks at one time. It creates one block at a time so that you will only create blocks what you require. But we still seen that there is a memory problem, memory leak problem even in dynamic memory allocation, because at least it's saving the amount of memory at the time of creation. But what if you change the memory, like as we did in Python, that I have created a block with a value called 10. Next time I created another block with value called hello. Then what happens when we create a next block of the same data or the other data? What happens to the previous blocks? They remain same. They cannot be reused because the block has been reserved. As it is nobody is referring to that, so actually they are eligible for deletion, but nobody deletes it because that is what we learn about manual memory management. Like manually you have to create and manually you have to delete the memory. That is a problem with C and C++ because it is manual work for allocating the memory and it is a manual work for deleting the memory. So allocating the memory, it's okay. That is our responsibility to allocate. But at least deletion will create a problem, because if you do not delete the memory, every time you need to check and delete the memory. So you have to write a separate code which will always check the memory which is eligible for deletion, and then you have to delete the memory, which is what this paragraph is talking about. Is not easy. It's a complex task. Okay, it's not easy task or non-trivial task for performing this manual memory management. That's why Python says that first thing in Python, we learn that there is no static memory allocation. Python always allocates memory dynamically, meaning Python always allocates the memory at runtime. Okay, and also we learned that all runtime memory gets allocated in the special area called heap area. Heap is a special area in your hard drive, which logical area where all dynamic allocation happens in the heap memory, because it can grow and shrink dynamically. So that's why all memory allocation will happen in heap. So that's why as Python follows always dynamic memory allocation. So that's why you will see that you will have a heap memory where the object gets created and all references will be created in the stack memory. Now what happens when I say a is equal to 10 or a is equal to input and user enters 10, then what happens at runtime? An integer object gets created and a reference gets created in a as in stack now. Then what happens if I say a is equal to hello? Then another object gets created in the heap area, which is nothing but the string object, and it will be assigned to the same reference called a. So a was previously pointing to integer object, now it is pointing to string object. That's why I told you a is nothing but an arbitrary object or arbitrary reference which can refer to any object. In this case, it can refer to integer object, string object, float object, boolean object, complex object, or to any object now. But what happens to the object which is no more have a reference? Then I can tell that they are eligible for garbage collector. They are eligible for garbage collector. So at least in Python, you don't have to write your own logic for garbage collection or for deletion. Python says that I will take care of deleting of memory. You just allocate the memory, take a responsibility of allocating the memory. I will take the responsibility of deleting the memory. When I will delete, it depends on the garbage collector algorithm. Okay, but as question has been asked that can we call the garbage collector? Yes, you can call the garbage collector, but it will not guarantee that it will run when you call it. It may run or may not run. That's what the thing. But mostly it will run. But sometimes it may happen that the garbage collector may not run. Okay. So later on we will see how garbage collector works in Python and what are the different algorithms we have for garbage collector. But now you should understand that there is a program called garbage collector in Python which runs in the background, and always it will check is there any object eligible for garbage collection. If any object is eligible for garbage collection, then the garbage collector will come and delete that object. Like in this example I shown you, like when I say a is equal to 10, a is equal to 2.13, a is equal to true, and a is equal to hello, then actually four different objects are getting created in the heap, but only one reference gets created because all the reference has the same name. So multiple reference will not be there with the same name. Okay, so only one reference gets created, but four different objects gets created. But every time the reference is getting changed. So first time it's pointing to an integer object, second time it's referring to a float object, third time it's referring to a boolean object, and fifth time it's referring to a string. Sorry, fourth time it's referring to a string object. Now finally it's referring to the string object. What happens to the other object? They are eligible for garbage collector because they are not referred by any reference. So remember, if they are not referred by any reference, then we can say them they are eligible for garbage collector. So this is what we have discussed in the yesterday's session. Any question regarding this first point called memory allocation in other programming languages and memory allocation in Python? I hope Rajshekhar, you got the point now. Any questions? How to store like you're talking about in Python, Ubul? How to store arrays in Python? Or you're talking about, okay, you're talking about how to store arrays in Python. So if you wanted to store array in Python, there are many ways. There is a data structure called list, which can store a collection of items. There is a module called array, which will also help you to store a collection of elements. And we have a special module which also deals with the thing called NumPy, which is numerical Python, which also deals with an array. So there are multiple ways to store arrays in Python. Okay, and all dynamically get stored. So that's the beauty again. You can simply create an empty array and you can keep adding the data whenever you require. Okay, Rajshekhar says that not 100%. It's okay, Rajshekhar. You can follow up, no problem. Every hard drive contains stack and heap or RAM also. See, basically, Satyam, what we are talking about is currently RAM. Because whenever your program runs, it runs in your RAM, right? Because the whole operating system gets loaded in the RAM. Until unless you save it permanently, it goes in hard drive. Otherwise, all your variables and everything will be created in RAM. So what we talked about is RAM actually. Okay, so your RAM or hard drive, whatever you call it as, memory in short, contains different memories, not only stack and heap, it also contains other things like native stack, okay, method area, heap area, and stack area. So multiple memories will be there logically, so that different things will get stored in different location. Like whenever you write the program, it gets stored in the method area, and then whenever your program starts running, then the stack area gets created and the heap area gets created and native stack gets created, where all your native functions which has been written in C++ will be present there. So different memories comes in picture whenever you run the program. Okay, so I hope Ubul confirms and Vamshi, Satyam all confirms now. Yeah, that's true. The data, the principle it follows is called last in, first out. Okay, that knowledge makes sense, but it's okay right now. Okay, because we're not understanding how stack works. Stack is a type of memory in Python which is generally used to store your references or local variables. Okay, so I hope I'm confirming the questions from everyone so that I can go for the next topic. Okay, shall we go for the next topic in memory management now? Okay, thank you, Udit. Thank you, Satyam. Thank you, everyone. So let's talk about, we already discussed about it. Let's have a glance again. So we already talked about variables. So C also follows stack and heap for dynamic allocation. Of course, every programming language. Okay, every programming language has a similar kind of memory like stack and heap and all. So everyone follows. So we already discussed about this statically typed versus dynamically typed language, right? So let us have little bit about statically typed versus dynamically typed. So our second point here is C, C++, Java. They all are statically typed languages. They are statically typed languages. Okay, and Python is a dynamically typed language. Python is a dynamically, okay, typed programming language. It's a dynamically typed programming language. So let's see a little bit about statically typed languages versus dynamically typed language. So we know that. First, let us talk about the Python. So what is mean by dynamically typed language in Python? So we all know that variables, okay, in Python will be decided at runtime. So data type of variable will be decided or declared at runtime. So in Python, we all know that it will be declared or decided at the runtime. So that's why it's called dynamically typed language. Dynamically typed here means data type. What is meant by typed here? Data type now. So meaning dynamically typed language. Dynamically means always at runtime. Always at runtime. So at runtime, okay, it decides that what data type should be allocated based on the value what user given or what you have given. Depends on that, the data type of the variable will be decided or declared at the runtime. So there is no way that you can declare any variable in Python saying that it belongs to integer type or float type or string type. You cannot say them. So it is totally a dynamically typed language. But in other languages like C, C++, and Java, other languages in C, C++, and Java, you must declare a variable. Okay, you must declare a variable at compile time. Okay, declare, must declare a variable, must declare a variable, okay, at compile time. At compile time. So you must declare a variable at the compile time. So it is mandatory to have a data type at the compile time itself. So that's why, for example, you can see here, for example, if you are using any variable, I hope you might have come across a very common problem in C, C++, and Java that you use a for loop like this. For I is equal to 0, I less than or equal to 10, okay, I plus plus. You wrote some logic like this, right? And you wrote some thousands of lines of code or hundreds of lines of code. When you try to compile this program, you end up with an error saying that I is not defined. Did you ever got this error? I is not defined or some variable is not defined? Very common error in C, C++, and Java, that especially because you know that in for loop, you wanted to use this variable only temporary purpose, only inside the for loop. And most of the time, as Ubul confirmed, that mostly you will end up with an error. This is a very common problem, but other variables also you may forget to declare and use them directly, and you will end up with an error saying that I is not defined, A is not defined, X is not defined, and saying that that variable is not declared. So directly started using them. So this is a very common problem. That's why C++ and Java has come up with a solution that okay, you can declare the variable inside the for loop also. If you wanted to use temporary purpose, you can declare them inside the for loop. But very true that you must declare the variable in C language, telling that in A, I belongs to integer or float or character, whatever, you must tell them what it belongs to. Okay. And also once you declare that variable of that particular type, it can never change the type. Do you agree now that it can never change the type of the variable? It will always remains of integer type. Roshan, actually, I just started for 15 minutes. We did a revision of what we discussed in our last session. It's just the thing. No conversion because string to integer and all like character to integer, or sometimes it may not be possible, or you have to convert them. Conversion is possible, Satyam, but you have to explicitly do them. But once you declare, you cannot convert also, Satyam. The value can be converted, but I cannot becomes to string data type or any other type. I will remain only integer. I will remain only integer, which is not true in Python. As it is dynamically typed language, it gives an advantage that we already seen that A can be of integer type, A can be of string type, A can be of any type. So you know that when I declare A is equal to 10, it becomes integer type now. It becomes an integer type. When I say A is equal to 3.14, it becomes float type now. It becomes float type. When I say A is equal to hello, it becomes a string type. So it dynamically changes the type. So when I say a is equal to 10, a never becomes an integer throughout the program. A can also becomes a floating point type. A can hold string also. At runtime, it will be decided, and memory wise, we have seen what happens internally in the memory. But in C language, once you say int I, then I will always contains integer variable. It cannot store any other type as well. So it is reserved only for integer only. So that's why you must know what is meant by statically typed versus dynamically typed language. Understood, everyone? Okay. Thank you, Naren, for confirming. Thank you, Satyam. Thank you, Bull. Thank you, Aditi. Thank you, Nitin, Nitesh. Roshan, will you confirm you followed? Because we already covered this. We already covered this, so that's why I have just given a glance of statically typed versus dynamically typed language. So in memory management, we have discussed 2 points till now. The first point was how memory allocation happens in other languages and how memory allocation happens in Python. That's what our first topic we discuss in memory management. So first thing we should know what are the different ways you allocate the memory in other languages and how you allocate the memory in Python. Here the comparison is required. Then only you can understand the difference between the memory allocation in other languages and the memory allocation in Python language. Then we talked about other languages are generally called it as statically typed language, but Python is called dynamically typed language. Statically typed language meaning Roshan, you must declare a variable at compile time. Using a data type, you must declare a variable at compile time. That is why it's called it as statically typed language. Statically typed means before you run the program, you must declare the variable because here the compiler is responsible for allocating the memory. Compiler is responsible for allocating the memory. But in Python, as it is dynamically typed language, you don't have to declare the variable. It will automatically declare at the runtime. So that's why it is called dynamically typed language. So in C, we have short int, long int in Python. Also, there are not. We don't have short int and long int Python, integer in Python Ubul. We have only 14 data types. There is only one integer type in Python. There is no long, there is no short, and there is no double or something. So we'll discuss about it. Roshan, is that clear for you? Okay, anyhow, I'll just give you, I'll show you in slides as well so that you can understand that what is mean by statically typed versus dynamically typed language. So declaring variables in JavaScript, Ruby, and Python is different when compared to languages such as C, C++, and Java, right? So declaring a variable in JavaScript, Ruby, and Python is different to in languages such as C, C++, Java. Why they are different? Why it is different? Why this slide or this paragraph is telling you that declaring a variables in languages like Ruby, Python, and all is different when compared to C, C++, and Java. Very good, Daljit. Very good. Because they are dynamically typed. Which are dynamically typed here? Which are dynamically typed languages? Very good. Ruby, Python, JavaScript. Very good. They are dynamically typed languages. Do you require data type to declare the variables here? Do you require data types to declare the variable? No. Very good. Very good. Okay. I was about to tell like there was like slow like the interaction became less, but now I can see that people are coming up, but not 100%. Like some people are silent. You also have to come up, guys, and you have to start talking because believe me, the understanding, the interest, and everything depends on the interaction mostly. Okay, so your interaction, your question, and all plays a very important and a key role in online platform. No doubt, we'll do our best to make you understand, but your interaction will give us confidence, will give us to go for the next topic. It gives us okay, you all understood, now I can go for the next topic. Okay, so that little request from everyone, please little more interactive, like try to be more. Sometimes can be unnecessary, but I'll be expecting you to ask some questions or tell something to us and all. Okay, so as you all told, that's perfectly correct, that this is because they are dynamically typed languages, right? So thank you, Vishwajit, that you understood that JavaScript, Ruby and Python are different from C, C++, Java because they are dynamically typed languages. What is statically typed languages? In statically typed languages, the type of the variable refers to the variable itself, not the value of the variable, right? It does not depends on the value of the variable. It refers to the data type actually. This means that when you declare a variable as an integer, only integer can be stored in the duration of the existence. If you try to assign a character, it will give you type error, or it will throw some error and your program will be crashed. Do you agree with this paragraph? What happens in statically typed languages? Okay, thank you Satyam for confirming. Thank you, Udit. Anybody want me to explain? I can explain, no problem. Okay, please let me know if you didn't follow. I hope it's very straightforward. That's what we discuss here. I told you here that if you declare variable I of integer type, then only you can store integer here. You cannot store a string. You cannot store anything. Okay, I will explain with an example now. Okay, I will explain this with an example. Okay, I'll take an example here. Tell me, like for example, if I declare a variable like this, if I declare a variable like this now, for example, if I declare int a, int a, can I store a is equal to hello? Can I store a is equal to hello? No. Ubul says no. Okay. Okay. Everyone says no. Why? Why we cannot store a is equal to hello now? Because I already said that a belongs to integer type. A belongs to integer type. I already said that. If I say a is equal to 10, this line will be valid, but this line will end up with type error. This line will end up with type error. That is what this paragraph is talking about. This, when you declare a variable as an integer, only an integer can be stored duration of its existence. Meaning in a, I can only store integer. It can be 10, 100, 1000 or whatever the value, but it should be integer only. Okay, it should be integer only. If you try to assign a character or a string or any other type, you will get type error and the program will be crashed. Now you all understood what does it mean? So a can hold only integer type now, because you already declared that it belongs to integer, that it belongs to integer type. But what if in a, what is in dynamically typed? For dynamically typed languages, the type of the variable refers to the value the variable contains. Depends on the value, the data type will be decided. It means that if you assign an integer to a variable, the variable type force to an integer. If you say a is equal to type 10 in Python, then a will become which type? If I say a is equal to 10 in Python, then a will become which type now? Suppose you say a is equal to 10. So a will become integer type. Very good. When you assign a string to a variable, then it enforces to string. Like when I say a is equal to hello, then it becomes string data type. So when the data type will be decided at runtime. Can you declare in Python something like this? No. You cannot declare a int a is equal to in Python. Okay, you cannot declare. So there was a question from Rajshekhar. If a is equal to hello underscore 2, then it will work. If b is equal to int a. Sorry, I did not get your question, Rajshekhar. You cannot use integer or float or something, Rajshekhar. That's what I am telling here, that you cannot use that. If you're thinking that you wanted to use int a or something, you cannot do that way. And also here, Python automatically assigns a variable the appropriate data type based on the value it is given. Do you all agree with this sentence? That Python automatically assign a variable the appropriate data type based on the value it is given. So this proves that it is dynamically typed, because here it is automatically assigning, automatically assigns at what time? At runtime. At runtime it will assign. Okay, at runtime it will assign. Explain the previous slide. Okay, I will explain. So in dynamically type, the type of the variable refers to the value of the variable it contains. Meaning, if you assign an integer to a variable, the variable type force to an integer, meaning it will be declared as an integer type. It will be declared as an integer type method. If you assign to a string, it will become a string type. That is what it means by dynamically typed, because here the data type is decided at the runtime. Here the data type will be decided at the runtime. Is that clear, Venkat, now? Yeah, it can call implicit, not conversion, declaration, Satyam. It's not converting from one type to another type. It's declaring the data type of that variable. It's implicit declaration. Okay, very good. So in Python, it is implicit declaration. In C, C++, and Java, it is explicit declaration, meaning you have to declare. But one difference is that at compile time or at runtime. So I told you Python automatically assigns a variable that appropriate type based on the value it is given. Meaning a variable with the value 7 is an integer, 7.0 is a float, and 7 is a string. Agrees again? Is this line okay? Okay, and also we've seen that you cannot declare. There is no declaration of variable required in Python. If there is a need of variable, you think of the name and start using it. You don't have to declare them. 7 in double quotes will be a string. Yes. If you write any number in double quotes, Nitesh, it will be treated as a string in Python. Right? If you write anything in double quotes or single quotes, will be treated as a string in Python. So in case of Python, for a variable duration of existence, can we declare two values like once an integer? No, you cannot do that, Aditi. Then it becomes list or something, because I told you list can contain multiple values like an array. Like an array, you can have multiple values to a variable, but not a normal variable. It becomes an array variable, like a list variable in Python. Okay, I hope you got it. So good question from Aditi. Can we declare string as hello 123? Of course, Venkat. You can declare hello string as hello 123 or only 123. No problem. You can declare because string is a combination of characters, numbers, any special characters, anything. Okay, it is a combination of anything. It should be in single or double quotes. Okay, very good. So I hope now final confirmation with everyone. So is this 2 points are clear? Memory allocation and second point about memory management. Okay, thank you for confirming. Let's go for the second thing. Okay, let's go for the third point now. Sorry, let's go for the third point here. The third point I would like to talk about. The third point I would like to talk about here is, okay, let us discuss this. So actually, when the thing like C, C, C++, and Java, C, C++, and Java has variables, has variables. Okay, they have variables concept. So your meaning, what does it mean? It means that okay, actually actually okay, it creates actually it creates a block of memory. It creates a block of memory. Actually, it creates a block of memory space, memory space, so that it can hold the value. It can hold the value for that variable. It can hold for that particular variable. Okay, for that particular variable. This is the definition of C, C++, and Java as variables. What is meant by a variable? Variable is nothing but the memory space, guys. What is variable in other programming languages? Variable is nothing but the memory space. Example, when you say int a, you know what happens in basically what happens when you say int a now? basically what happen is 2 or 4 bytes of memory will be allocated, and the name of this memory block is A, and it will have some address like 2001, and some initially it will contain 0. Initially it will contain 0 because you already said that I am declaring as an integer type, so by default it will assign a 0 to this particular block now. So that's why I told you C++ and Java has variable. Now if you wanted to tell, if you want to ask me, what is this A? So A is a variable here. A is a variable here. 0 is a value here now. 0 is a value, and this is the address. This is the address. So this is what happens when you create a variable in C, C++, and Java. This is what happens when you create a variable in C, C++, and Java. So C, C++, and Java has variables concept, but there is no variable concept in Python. There is no variable concept in Python because Python variable are reference to the objects actually. Okay, Python variables. There is no concept of variables actually. No variables in Python. Python has name. Okay, Python has name, not variable. So I can say something like this: Python has name. Name. Okay. So what is mean by Python has name, not variable? It means that Python variables Python variables are Python variables are reference to objects. Python variable are reference to objects, but the actual data, but the actual data, but the actual data is contained. Actual data is contained in the object. In the object. That is what you need to understand here now. So Python has no variable concept, but it has a reference concept actually. That means C++, no stack heap reference method. It is there. It will be there. Memory space means it can be stack or it can be heap. Depends on the variable created, whether it is created statically or whether it is created dynamically, Satyam. So we do have stack and heap concept. Memory space can be in stack or memory can be allocated in heap. Depends on the like whether it is statically created or whether it is dynamically created. We do have stack and heap as well, Satyam. But it means they are variables actually. They are variables. Okay, we will understand this concept much better when we go for next point as well. But I will try to explain you now. I'll try to explain you here that Python has names, no variables actually. Okay, Python has names, not variables. So what does it mean? We know that when we example, if I declare a variable like this, let me use the same color. For example, if I declare a variable like, if I declare something like this, a is equal to 10, we know that what happens here now. We know that what happens. Here, a memory block, as we seen in C language and C++, it's not going to create me a memory block actually. We all know that an integer object gets created. An integer object gets created with a value called 10. So that's why I told you data is actually contained inside the object. Data will not be contained inside a variable, so A is not a variable. If I ask you what is A here, you will tell me A is a reference to an integer object. You will not tell that A is a variable in Python. Instead, you will tell that A is a reference to integer object because actually A is referring to this integer object. A is referring to this integer object. And we all know that, okay, this will be created inside my heap memory. This will be created inside my heap memory. I can change the color, and this will be created inside my stack memory actually. This will be created inside the stack memory. So A will be created inside the stack memory, and this will be created inside heap memory now. So this is my stack memory here, and this is my heap memory. And this is what happens in Python has names or the references, not the variable concept. So Python variables are references to objects. So if you say A here, A is not a variable, A is a reference to that object. But where the data will be stored, actually it will be stored in the object now. So it says that what is this one? It says that I am an integer object. It says I am integer object. I am integer object. And what is this A? It says that I am a reference. I am a reference. I can refer. I can refer to any object. I am a reference. I can refer to any object. I can refer to integer object. I can refer to string object. I can refer to float object, or I can refer to any object. Is that clear all? Is that clear everyone? Okay. Thank you everyone for confirming. Let me just wait here. Yeah, Satyam, I would like to answer what is this confusion about. Okay. I think, okay, I will explain you, Satyam. Is it okay if I do it at the end of the session? I think next point will make it clear. If not, I will definitely do that. Yes, of course, I will show you that stack and heap in this particular thing as well, Naren. Okay, I will do that. I will show you if you want. Let us do that in the next example. Let us do that in the next example. Okay, let's try to do this. Now, the fourth point I would like to talk about here. The fourth point I would like to talk about is about memory management. Most important point. Okay, memory management in Python. Memory management or memory creation. I can call it as memory creation. Okay, let us talk about memory creation in C language and memory creation. Yeah, no problem, guys. If you are not clear with stack and heap, I will make it clear, no problem. The only confusion, as Satyam also concerned, that how it happens in C and C++, that's what everybody is concerned. Everybody is concerned is how it happens in C and C++. Let me try to clear with this example. If not, I will explain you at the end of the session. You can stay back, those who have a doubt. They can stay back so that I can talk little more about stack and heap now. Okay, next 15-20 minutes. Try to spend understanding this second, fourth point. Okay, so are you all with me now? A small confirmation. Okay, thank you, Satyam. Thank you, Udit. Yeah, thank you, everyone. So let us start discussing about memory creation now. This is a little important point, so I want everybody's attention. Okay, this is little important, so I want everybody's attention. Now, how you create memory in other languages and how you memory gets created in Python. How the memory gets created in Python. For example, you know how we create a memory in C language. Now, if I say int a is equal to 10, int a is equal to 10. Couple of questions to everyone, especially who has a little confusion regarding stack and heap in C, C++. It can be any language, guys. I'm not only talking about C, C++, Java. It can be any language other than Python. So when I say int a is equal to 10, couple of questions to you. First question is it static memory allocation or dynamic memory allocation? Is it static memory allocation or dynamic memory allocation? Very good. So Udit, Santosh, everybody says it is a static memory allocation. Very good. Very good. When I say A is equal to 10, is it static memory allocation or dynamic memory allocation? Dynamic. Very good. Because memory will be allocated at runtime. See, I'm not talking about data type again. I'm not talking about data type. I'm not talking whether it's statically typed or dynamically typed. Data type is different, memory allocation is different, guys. So I'm talking about here, the memory allocation is will be decided at compile time or runtime. So this will be decided at compile time, this will be decided at runtime. So whenever the memory allocation happens statically, so where this A gets created? In stack or in heap? Where this A gets created? In stack or in heap? Okay, Aditi thinks in stack, Naren thinks in stack, Santosh thinks in stack. Okay, everyone thinks that in stack. Very good. Because remember, variables will be created in stack. Only when you create memory at runtime, then only the heap comes in picture. Otherwise, it will always allocate in the stack memory. So there is no confusion, right? There is no confusion. So here the only stack comes in picture, but as in Python, it is dynamically allocation. That's why the memory will be allocated in the heap area. So that's why we can see that heap is getting created. If I use malloc and all, then the heap comes in picture in C language as well. When the memory happens allocation at runtime, as I shown you here in my first example, when I use this malloc function and all, then I told you this will get created in the heap memory and P will be created in the stack. Did you all remember? I told you this example. Then in C, the heap and stack comes in picture. Okay, thank you Aditi, thank you Ubul for confirming. Others, will you confirm now? That's why you don't see the same diagram now. That's why you don't see the same diagram, because here only the stack comes in picture, not heap. So that's why I'm not showing you the heap memory right now. The heap only comes in picture when you allocate the memory dynamically. In Python, there is only dynamic way of allocation memory. That's why every time I'm drawing two diagrams, stack memory and heap memory. But in C language or C++ and Java, there are two ways. Stack is a variable. No, stack is a memory, Nitesh. Stack is not a variable. Stack is a memory name where the variable gets created. So now you can imagine here a stack is getting created and inside the stack the variables are getting created. Now you can imagine a stack is getting created now. This is my stack memory getting created and inside that stack memory the variable gets created. Understood everyone? This is my stack memory now. This is my stack memory. And inside the stack memory, what happens? The variable gets created. The variable gets created. The first variable gets created A. The first variable gets created A here. Okay. The first variable gets created A. Okay, let me use a different pen. Sorry. Okay, the variable name is A and the value is 10 and address is 2001. Do you all agree? I will explain. That's what Satyam. I will explain the dynamic allocation in C language at the end because that is not the agenda for the session because we are not learning C, but I can add on. That's not a problem. Because again, the syntax will be a different. So I hope you should follow the syntax. But I will show you how we allocate the memory. So when we allocate the memory dynamically, then stack and heap remain same as it in Python. Yes, Naren, that's true. The same thing, the same diagram I will draw when we allocate the memory dynamically in C language. Okay, very good point from Naren. So I hope that makes sense to everyone now. The diagram will be remain same. So don't worry about it now. Getting my point, everyone? Satyam, I hope you got it now. Okay, thank you. Anyhow, I am going to show that as well. I'm going to show that. Okay, for time being, let me show you what happens now. For example, if I create a variable called D, if I create a variable called D here now, for example, I create a variable like D, I say like this, int star D is equal to malloc, int star D is equal to malloc, okay, 1 into size of integer, and then you typecast to integer. Then what happen is this malloc will create the memory in heap. This malloc will create the memory in heap now. So heap is getting created now. In this case, a heap memory will be created. A heap memory will be created. Now this block will be created inside the heap now. This block will be created inside the heap. Let me change the color. Okay, this block will be created inside the heap and reference will be created inside the stack. Reference will be created inside the stack. Now A will be created inside the stack. Sorry, D will be created inside the stack and it will be referring to this. And when you assign a value to this, the value will be assigned maybe like, for example, 40 and some address like 4001. And this is how stack and heap comes in picture. Understood everyone now? When you do this line, then heaps in comes in picture. So same diagram as we did in Python. As we are declaring statically, that's why I'm showing you stack. Okay? Satyam, is it making sense now? Thank you. Thank you for confirming. Yeah, same as every language, Santosh. It is same in every language. It depends on static allocation and dynamic allocation. Okay, thank you everyone for confirming. Now tell me. So that is additional thing. So as based on question I have answered. So don't worry about this. You will, if you wish, you can learn in C language, but the diagram will be same. If you're getting confused with memory allocation in Python and memory allocation in C language, everywhere it is same. But the only thing is depends on the type of memory you allocate, statical or dynamic. Now tell me what happens when I say int b is equal to 10 now. Anybody? What happens when I say int b is equal to 10 in C language? Please explain this line. I hope everybody understood the first line and last line. Now tell me what happens when I say int b is equal to 10. Okay, Santosh thinks that another space will be created for b. Where, Santosh? In heap or in stack? Very good. In stack, another space will be created. In stack, another space will be created now. Okay, another space will be created in stack. Okay, and who is pointing? Who is actually the name of the variable is b, right? Variable of name is b, and the value will be 10, and address will be 3001. Do you agree? Do you agree this? Very good. Very good. How can you prove that? How can you prove this diagram? How can you prove this diagram? How can you prove? How can you say me that two blocks are getting created now? If I ask you a proof, okay, you told me when I say int a is equal to 10, okay, so by using checking their addresses, very good, Aditi. Addresses will be different, very good, safe. That's what our concern, that addresses are different. So that way you can say that there are two different blocks are getting created. There are two different blocks are getting created. Let us see practically. Let us go here. I have an editor called DevC where I can run my C programs. Okay, I will open some program like main.c. Okay, here you have some program. So let me remove the things here now. Okay, this is my basic C program. I don't have to explain you anything. I just wanted to say you what happens now. We say A is equal to 10. We know that a memory gets allocated. When I say B is equal to 10, another memory gets allocated. Can I print their addresses? Yes, I can print their addresses. I have to use printf, and for addresses I will use percentile %u and percentile %u. So I'm printing A address and B address. I'm printing A address and B address. So I will say address of A and address of B. So this is how you print addresses in C language. So this is C language code, guys. So obviously it will be different from Python. But at least after learning Python, you can follow Python. If even you are not from C background, I hope still everybody can follow up this program, because I'm declaring variable A, I'm declaring variable B here, I'm printing the address of A and address of B. So here you will notice here, if I run this code now, you will see here A address and B address will be printed different. You see here 6487580 is an address of A and 6487576 is an address of B. Are they same or different? Are they same or different? Very good. They are different. They are different. Very good. So it creates unique blocks actually. It creates unique blocks. So this proves our diagram. Do you all agree that it proves your diagram now? So different for each input, this will be different. Very good. Very good. Now let us talk about what happens when I say A is equal to 10 in Python. What happens A is equal to 10 in Python? Please tell me. What happens when I say A is equal to 10 in Python? Will it get created in stack or in heap? Okay, memory will be allocated in heap, very good, and A will be created in stack, very good, very good. So here again there are two diagrams. There are two diagrams. One is stack memory, and another is heap memory. I'm just referring this diagram so that I can make it different. That's not true real time, just to show you. So here we have two diagrams now. One is called stack, the other one is called heap memory. So we know that when I say A is equal to 10, what is going to happen is an object gets created here with a value called 10 with some address like 2001, and a reference will be created. A reference will be created in the stack memory, and that will be referring to this, and the value will be 10 here, and address will be 2001. Do you all agree? Do you all agree? Because it is dynamically typed, so that's why all dynamic memory allocation happens in heap area. That's the only reason. Looking alike, but as it is dynamically allocation, because the first point I told you, Python always allocates the memory dynamically. I told you Python always allocates the memory dynamically. So that's why I'm showing you here that as it is allocate the memory dynamically, that's why the heap memory comes in picture and stack comes in picture. Okay, so that's what our next question, Nitesh. What happens when I say b is equal to 10 now? What happens when I say b is equal to 10? What happens when I say b is equal to 10 now? Okay, b in stack and 10 in heap. Okay, so that's what you need to understand here, that how memory is going to be allocated. That is what you have to understand here, how memory gets allocated now. So remember, in heap, what happens is Python has decided, because there will be a problem, because heap is fixed in size, you may get some problem while allocating of memory. Python has decided some principle. Let me talk about it, guys. Let me talk with an example now. For example, let's take a real-time example to understand this scenario. Let us take some real-time example to understand this scenario. For example, we have given you to fill the form. We have given you to fill the form. I want you to fill your name. I want you to fill your name. Okay, fill your name now. Here there is a block called name, and I want you to fill the institute name. Institute name. Okay, institute name. For example, there are around some 2000 students will be filling this form for name and their institute name and other information. Okay, so you will fill your name here, you will fill your name here, and you will fill your institute name here now. Okay, so every student will have a different name. Do you agree? Every student will have a different name. Okay, very good. And institute name will be same for all of them. Okay, so my question here is, uh, for name, there are 2000 objects to be created. That is true. The 2000 memories to be allocated for name, because there are different names. But do you require to give 2000 memory for institute as well? Because you all belongs to same institute? No, right? So do you agree here, at least because NIT, Naresh IT is the institute name. So do you agree that one object is enough for that? One object is enough, and all 2000 students are pointing to same object. Do you agree? S1, S2, S999, whatever. Okay, whatever, if it is 1000 or something. So all are pointing to the same object now. So that's what Python says, that Python, what Python does is, whenever you create any, whenever you wanted to create any object, like when I say A is equal to 10, when I wanted to say B is equal to 10, then what Python will do actually is, it will check, do we have already an object called 10? Do we have an object already called 10? If there is an object called already with a value called 10 in Python in the heap memory, then it will not create another object. Simply a reference will be created in the heap stack, and the same reference will be means reference will be pointing to the same memory now. Understood, everyone? It's not like in C language. In C language, what happens? Two different memories got created. We already proved it by printing their addresses. But here, to save the memory, heap memory, Python people has decided, because stack memory gets automatically deleted when the program is ended. But in the heap, the data will remain until the garbage collected. The data, it will remain. So to save that memory, Python has decided that it will always check that whether it is memory get allocated. So that means it will have same address. That's true, Abhishek. It will have same address now. So both A and B is same address for memory 10. How to check in Python? I will show you. But you understood now how memory gets created in Python and how memory gets created in C language? Okay, thank you. I will prove you whether they are same addresses or not. I will prove you. Now I'll go to Python IDE or IDLE. I will run that in shell itself. I will run and show you in the shell. I will say A is equal to 10. You know how it happens internally. And when I say B is equal to 10, you know that B also 10 is only one object. So how many objects gets created now? How many integer object gets created? Only one integer object. That's true. Only one integer object. How many references are getting created? How many references are getting created? Two references. How can I print that? I can print the ID of A and I can print the ID of B. I can print the ID of A and ID of B. So we have a function called ID function which will print the address of A. Which will print the address of A. So ID of A and ID of B will get printed same. You see here, it's getting printed same now. So this proves that both are pointing to same location. Both are pointing to same location. So in C, dynamic memory allocation, how it allocates two value same as in Python? No, not as in Python. Python has this principle, not C language. At least not for integers and all, because they are not objects. Everyone understand? No, not exactly, Venkat. Okay, it's logical memory, both stack, heap, and all will be created at the time of running of your program. Okay, now tell me what happens when I say C is equal to 20. What happens when I say C is equal to 20? Or C is equal to 11? Or C is equal to 11? What happens in the diagram when I say C is equal to 11 now? Okay, so let me explain you. So if I declare C is equal to 11, then you all know that it will go and check. Do you have an object called 11 here? First it will check. Do you have an object called 11? No, it will not. So Python gives importance to value and C++ give importance to data type. Yes, variable. SK, it gives importance to data type or the variable, but it gives importance to the value. Okay, so very good. So now what happens? First of all, it will go and check, do we have an object called integer object with the value called 11? No, it does not have it. So it will create an integer object now. It will create an integer object now. So an integer object will be created with some other address and 11 will be assigned here. 11 will be assigned and C will be referring to 11 now. C will be referring to 11. Okay, C will be referring to 11. Now if I go and print the ID of A, B and C, what do you think? ID of A, B and C. Do you think are they same now? Are they same? Are they same? No. A and B will be same but C will be different. Do you agree? A and B are same and C has a different address. Very good. Because it's a different memory. Different memory. What happens when I say D is equal to 10 now? What happens if I say D is equal to 10? What happens if I say D is equal to 10? D is equal to 10. It will go and check. Do we have an object called 10? Yes, we already have an object called 10. So when I say D is equal to 10, so D will also be referring to object called 10 here. Now I will answer Ubul. I will answer now. As the data type changes, so memory will also change Ubul. Okay, data type is different. So now you see here, if I print the ID of A, ID of B, ID of C, as well as ID of D, you will see here first, second and fourth addresses are same, only C address will be different. Only C address will be different now. A, B is also same, will not be deleted as it is references, yes. That's true, but we will talk about in detail tomorrow. Okay, we'll talk about in detail tomorrow. Last session on memory management tomorrow. Okay, we'll discuss. Anyhow, 4 points we have covered. There is one more point to be covered, and then we will conclude the memory management. Is that clear for everyone now? How the memory management happens, how the memory creation happens in Python? So it will always check that do you agree that in heap there cannot be two memories with the same value? Do you agree? In heap, there cannot be two memories with the same value. Okay, there cannot be two memories with the same value. So if it is a value is same, all of them are referring to that memory now. So is it not saving the memory? Is it not memory utilization? Right? This decision has been taken for memory utilization, because you see here, otherwise I might have created unnecessary 2000 objects for storing NIT. Now I will create only one object. So I have saved a lot of memory. I have saved a lot of memory. That was the principle this Python follows. This is the principle Python follows whenever you allocate the memory. But in C language, even if you create hundreds of memory with the same value, then 100 blocks will be created in the stack memory. Or whether it is a heap memory or stack memory, 100 of blocks gets created now. That is, the memory creation is different from C to Python. Won't it have any drawback? So many variables are referring to same value? No, it will not have any drawback, Aditi. How to check address of stack for A and B and C, D? You can basically not directly, because Naren, in C language they give pointer concept is there, but there is no pointer concepts in Python, Naren. So it will not allow you to check that. Got my point now? Okay, so there is no pointer concept in Python, so they will not allow you to check that. How the address is executed means, I didn't get you, Nitesh. How the address is executed means? No, stack memory is fixed actually. Heap is not fixed. Stack is fixed, but heap is not fixed. Heap can grow and shrink. Okay, based on that memory, heap can grow and shrink, but stack will be fixed actually. I hope all the 4 points are clear regarding memory management. I hope all the 4 points are clear for everyone. Anyhow, last point I will revise tomorrow again. So if you have any doubt, please join at sharp 7. You will get more clarity about this fourth point, especially. The fourth point, I will try to elaborate. This week we will not have Sunday class, Vishwajit. Okay. As for previous batch, still I have few Sunday classes. So we'll start sometime later, not now. Because Sunday we will take only extra classes, extra topics, not the regular topic. Because still we are running regular topics. So Saturday we'll have the same time. Saturday we'll have the same time. Yeah, we have class tomorrow, Udit. Okay, there will be class tomorrow. Yes, Aditi, that's true. That's true. Okay. So anyhow, Venkat, I'm not sure. I need to talk to that people, because whether, because still students are joining. I hope some of you have joined yesterday or day before yesterday, right? Some of you might have joined yesterday or day before yesterday. Yeah, thank you, Bull. Thank you for that. Okay, so that's good to hear, and I can see that attendance is full every day. Okay, yeah, that's good. That's what, once that attendance is fixed, guys, we will make a WhatsApp group, because adding a person and deleting will not be a good. So that's why we are waiting. So no worry, still we are going very slow, and this is theoretical topic, because we once we go completely into practical, then our group and everything will be required. Don't worry, be relaxed. Just follow my classes for 1 or 2 days, no problem. Okay, by next week we will get confirmation, so we'll make a WhatsApp group. Okay, yeah, so I hope please go through with this. Yeah, thank you, Naren. We'll be having a lot of great sessions after that. Okay, but tomorrow we will get the conclusion, guys. I'm sure about the fourth point and all. You might have followed what I told you, but a lot more to be discussed tomorrow about this particular memory creation. We'll discuss little more about tomorrow. So the conclusion for memory management will be tomorrow. So please don't miss. As it is weekend, I can understand you may be having an holiday or something, so you have to woke up, so please try to manage, but tomorrow we will conclude on that. Okay, so this is all for today. Tomorrow we'll continue and we'll discuss more about memory management. Yeah, thank you, Udit. Have a nice day. See you all tomorrow. Have a nice day, Venkat. Thank you all. Thank you, Bull. Yeah, thank you. Yeah, definitely, Aditi. We'll have a lot of great days from now. Yeah, thank you. Thank you, everyone.